So our next application that we're going to look at is rates of change, because a derivative is that it's the slope of a tangent, and anytime you're talking about a rate of change, you're talking about something changing per minute, something changing per hour. That can be related back to a slope. So here we've got an equation for the number of bacteria in a colony after T hours. We want to find the growth rate of the colony after 10 hours. So what we're finding here is at 10 hours, we could say that this colony is growing at a certain rate. How fast is it growing at that specific time? It's an instantaneous rate of change. So what we're going to try to find is the tangent line right at that point and find the slope of that tangent at that point. And so when we take the derivative of this, it just becomes 6t plus 15. After 10 hours, 60 plus 15 is 75. So we can say, and since it's a word problem, we'll write it as a sentence. The rate of growth is 75 what? 75 bacteria per, and what is our unit of time? Per hour. So at this moment, after 10 hours, the culture or colony is growing at that rate. So it gives you an idea of what's happening at that moment. Show that the number of organisms will always increase. So another thing we can do is we can look at our function here, which is 6t plus 15. I'll rewrite it here. We know that our derivative, and to find out where it's increasing and decreasing, well, we've done that with our graphs already. We set our derivative equal to 0. And we get one value. Negative 15 over 6 is equal to t. So on our chart, we would have negative 15 over 6, or 2.5, as our time. And if you plug something in before negative 15 over 6, you will get a negative number. And if you plug in something after negative 15 over 6, you'll get a positive number. Now, according to this chart, the graph is sometimes decreasing and sometimes increasing. But now, in our situation that says show that the number of organisms will always increase, how does this show it always increase? Right, we've got to sort of think of 0 somewhere on here, right? And we can't go back in time. So starting at time 0, yes, the organisms are always increasing. So after t equals 0, the graph is always increasing. Now, is this realistic?
No.
Why not?
Because the organisms should die.
Right, they could die, but why can't they die and increase some more? What?
Because bacteria load bearing. There's a certain point where
We've got a certain situation where food's going to run out, or you're going to have problems with the environment with that many organisms. So there is a branch of mathematics called chaos theory that looks at those situations, because populations will grow, and then at a certain point things go bad, and then over the next period of time, like let's pick rabbits. Rabbits grow. Rabbits increase in population, but eventually they're going to get to a point where there's too many rabbits to increase at the rate that they're increasing, and food's going to become scarce. And as a result, chaos is going to happen for a while, and population might drop down, and then eventually it will reestablish its trend like it would normally go. Or they all die out and they go extinct. I don't know. Just so. Mosquitoes. This is anticipation question. Spring still has not arrived. It is colder than normal at the end of March and beginning of April. And so this is about the only time of the year I can think where the prospect of mosquitoes might be a positive thing, because we're so waiting for it to warm up. But it's in a controlled laboratory, so and we've got our equation there, and this equation, you might recognize its format from grade 12. Used to call these the Pert formulas. The Pert formula is a formula that represents continuous growth. So we'll talk a little bit about that formula with this situation after we solve this question. So T is measured in days. Find the growth rate of mosquitoes after 5 days. So anytime we're finding a growth rate, a rate of change, we're going to find the derivative. How good is your derivative skills with this one?
0.09.
What's going to we have the 250 e to the 0.09 t multiplied by 0.09. Because your derivative of e stays the same, but we have a chain rule. All right, how's your mental math? What's you want to simplify this?
Oh, it'd be like 25, a bit less.
Is it 22.5? Can you check that?
I said it was less. I'm talking about the file. Yeah, because I rounded it up. Oh, wait, I rounded it up to 0.1.
And then after 5 days, well, this for sure we're going to have to use our calculator for. $1.86. Okay. We're doing mental math competitions here. I like this one. That's what I'll type it in. Okay. What's your mental math answer for this?
He's close. He said 42. I'll say like 38 to 40. I think it's E. Like E to the 45.
So we were finding growth rate. I will round it to the nearest mosquito.
Oh, come on. You get a point. You made it.
35 mosquitoes per, and what was our time measured in? Days. Which is a really, you know what, if mosquitoes, there was only 35 more mosquitoes per day in Winnipeg, I think we would be doing very, very well this summer. Yes, I think.
Yeah.
Oh, I was going to talk a little bit about the formula, the Pert formula. So, the Pert formula, notice if you put a 0 in for t at time 0, anything to the power 0 is 1 for exponential functions. So the 250, that represents the initial amount. The r part is your rate. So in this one, the 0.09 would represent 9% per year. A 9% growth rate per year. How do I know it's per year? Well, when you're doing your compound interest, time is always in years. And I know that as you compound continuously, that's compound interest formulas in years. So why did they just, the formula is in years, it was,
Can't really convert it from hours to years.
so, yeah, I don't know.
Time is in hours and then
Yeah. So in this one, well, this one's in days, so this would be 9% per day, which isn't very much. Because if you think about 10% of 250 is 25.
Yeah.
So in one day, it's changing at 25 per day. But after 5 days, you would have more mosquitoes. And so then you're already up to 45 per day. Whew. Or 30, what were we at, 38, 35?
Actually, it was
35 per day.
7.
So does it seem realistic if it's 10% per day?
Yes, you can.
Well, like if you're a small bait. Actually, yeah, I remember earlier this year.
All right. Hot metal bar placed in an environment where the temperature stays constant at 34 degrees, much like this classroom. Here's our model for temperature. T is in minutes. Find the rate of change of the temperature 10 minutes after it was placed in the environment. So at time 0, this bar is at 124 degrees. Can you see that at time 0 it's 124 degrees? And temperature, the way that temperature works, you put something hot in a cooler environment, it will heat up the cooler environment, but it will cool itself in the process. Okay. I have a physics question for you guys. My physics is, I was sitting in a spot where I could see my shadow. The sun was coming through a window behind me, and there's the window frame here, so this is shadowed on the ground. Here's my head with ears, shadowed right there, okay? And there's also a shadow. There was a window here and a window on the other side of it as well, so it was just a thin part of 2 windows. Now, I found it interesting because I was bored and I was looking at my shadow, and as I moved my head towards the window frame, the following happened. So, oh, this is perfect. Infinite cloner. So my head didn't change, and I moved it closer here. When I got there, all of a sudden, the shadow of my ear elongated and connected. What's happening?
It's like a trick with your eyes because there has this shadows, like the darkest part of the shadow is right behind there's a certain point at your head where it's the darkest and it gets lighter and lighter because like the light can diffuse around it.
Right. So that's what I was imagining, the light bending around and coming, and my ear hitting the light rays where the window frame was, and now it couldn't bend because it couldn't actually get around it. Is that what's happening?
It doesn't have to, like, it doesn't actually talk like the bending really. It's just because like the.
But it was really weird because you could actually see my ear bend and jut out and connect.
Yeah, like how is this?
I don't know.
What is it? It's like the shadow is like dark at a certain spot and then it gets like it's still dark.
Oh, I thought I'd paused it. Okay, well,